and we have basically seen radial and mesh, and we did not discuss mesh in further detail because whatever in the indices you are determining here in this distribution system are applicable to mesh networks. It's very complicated. If you want to do research in that area, you can apply that. So we started with what we did? We started with distribution system reliability. And we approached it with two different ways. One was probability, and the other was frequency of distribution. Then next we find out how the for generation system only. We are considering only generation system. For almost 2 modules, 2.5 modules, we discuss generation system. Then a little bit we discuss transmission system. Composite generation and transmission systems are very reliable. We know all about that. So generally transmission system reliability is evaluated in conjunction with generation system reliability. Distribution system reliability is completely different from all this. Okay. So you can consider this to be one unit where we combine generation and transmission system. The first 3 course outcomes are related to this, which are basically generation systems. A little bit of transmission system interconnection and OR on that. Whereas this is more important from the consumer perspective. Distribution system. Now again, we are going back to what is part. We are again going back to the generation system. Okay. But with a twist. So there we considered a single generator as available or unavailable, where the generation was mostly one power plant. Okay. Whereas here we will see the details of the power plant. Details of the power plant. Okay. First 2 classes we will see the generator and transformer configurations, how they affect the reliability of the power plant itself. Then we will extend this. In one class we will cover both this, which is auxiliary system in a power plant, their reliability, and how to allocate spares. As you know, every system in the power plant has spares. Okay. So how allocating spares affect the reliability. And one class we will apply to protection system reliability. Protection system should be highly reliable. In fact, this should be completely reliable. If the protection system fails, then the power system will fail. So that protection system reliability is evaluated using a very different approach known as fault-free or event-day approach that we will see. And in the last class, we will discuss about the most popular test system for power system reliability known as the RPS reliability test system and its modifications, and we will see some latest research papers where the concept that we have learned till now has been applied. So we start with today generating plant activity. Today's topic is generating plant activity. Today's topic and tomorrow's topic will be similar. Generation and transfer. Generating plant and transfer. So what are the concepts have presented generating units by a single component system in module 1. Okay, where we discussed the generator to be either available or unavailable. Okay. The reliability indices were converted together to form the regression model for evaluating this. Okay. The reliability indices were converted together to form the regression model for evaluating this. What were the risk indices that you have used in this case? These indices, what are the risk indices for module 1 for generation system? You should not forget that. That is something that you should remember even after 10 years. What are the basic reliability indices for a generation system? These three things even after 10 years also you should remember. You have forgotten the whole of what's reliability, but these three things you should remember. Loss of load expectations, loss of energy expectations, and capacity. Now this single component interpretation is necessary in the assessment of large system in order to reduce both the computer time storage. So we need not bother us about what is happening inside the plant. We don't bother about. The system planner is not concerned about what is happening inside the plant. He is concerned about whether the plant as a whole is available or not. However, each of the single components are a system of their own. This single components are a system of their own. And system composition have a marked effect on availability. So how the system has a marked effect on the availability. So what configurations for generally used? So here basically we discussed turbo alternators, steam power plants. So a generating unit consists of a turbo alternator set and one more boiler having the following configuration. Unit system, one boiler for each generator. Set is a generator. And here rail system where one boiler is actually with more than one set. Draw this. Okay. We'll start with our first problem. So mention the numerical values. Okay. You have already drawn the diagram. Though I have shared the slide, don't see the answer. First try to find yourself. Consider a unit system having two generators and one boiler. For each generator. So you have got two generators and one boiler. Each unit can output 60 megawatt. So you have mentioned here 60 megawatt. So the capacity of the generator is 60 megawatt. That means boiler capacity should be at least 60 megawatt. I am talking about output, not the input. Input is less. Okay. The boiler output is 60 megawatt. Generator output is also 60 megawatt. Each boiler has an availability of 0.91. Mention that. So the boiler availability is 0.91. It is available for 91% of the time. Rest of the time it may be under maintenance, maybe out of service. And generator availability is 0.88. Okay. So if the generator availability 0.91, boiler generator is 0.88. What is the unavailability of the boiler? 0.09. What is the unavailability of the generator? 0.12. 12%. Each unit therefore has an availability of. So each unit means the whole set, boiler generator set. So that is simply you will multiply 0.91 into 0.88. 0.8008. That is the availability of the whole one row. Okay. Build the reliability model of the complete system and compute the expected output. Okay. So your task is to build the reliability model. So how you build a reliability model? By means of capacity of the statement. Right. So here I will say available capacity.
Sir,
into 0.91 into. So capacity केते available हे करियो पहले कौन कौन से देखो उतने होची what is the maximum capacity available 120 the maximum capacity available is 120 and next is 60 because one that you what is it out here 60 the third one is 0 so that means capacity out you can also write capacity out is 0 capacity out is 60 1 capacity out is 1 so what is the problem what is the probability that both units are available what is the availability of one unit one set 0.808 that is the availability probability of one system so that means there are two systems okay so I would say 0 is out so what is the unavailability 0.808 that is the availability unavailability 0.1992 sure yeah doesn't matter to the power 0 because it's out then 0.8008 square that means 2 minus 0 so how much is this it is simply 0.8008 square isn't it because 2 0 is 1 119 to quota so it has the availability of the whole set unavailability 1 minus 190 okay tell her how much 0.8008 square now what is this case we will say out of two states one is unavailable so that means 0.1992 1.808 so how much is this कितने दूसरी वन का कितने दूसरी वन is 2 दूसरी वन is 2 now what about average capacity 0 that means both are out 2c2 square
0.039
680 write it down now we check the answers if you are correct or did you make some mistake did you write the answers But question is what is the total available capacity? So the expected capacity is expected megawatt is equal to 120 into probability plus 60 into probability plus 0 into this probability. What is that? Compute. What is the expected output in megawatt? Compute. Okay. The total available capacity is equal to 120 into how much is this? Compute. Next, example 2. Consider the previous question, but each unit now is equal to 40 megawatt boilers meaning each set. All other data remaining unchanged. So what it says? So how many units are there? 60 megawatt. What is 60 megawatt? What is generator? One generator is 60 megawatt. It says the data engine, same data. But last time you had one boiler for one generator. But here you have what it says. Consider the previous question. But each unit is now with 240 megawatt boilers. So you have what? Boiler 40 megawatt. Job is boiler 40 megawatt. Okay. Again, this unit also boiler and generator. Consider the previous question, but each unit is not in 240 megawatt boiler, it is set. All other data remaining okay. With the reliability model and compute the expected output. Okay. So you have what? Each unit having 240 megawatt boilers. So expected output again, how to obtain the expected output? You will find out each of the states and their probability. Then multiply. When? Now tell me, available capacity category. Suppose each unit 60 megawatt. Forget about the second one. Forget about this one. Consider it as separate. We consider only this. So what are the available capacities for this? 60 megawatt. Then 80 megawatt. Is it possible? Even both the generators are, both the boilers are on. Maximum capacity is 60. So that means 40. If one boiler is out, its output is. If no boilers are out, if both the boilers are out, output is. Got it? We are considering only this unit, a single unit. And for the single unit, the available capacities can be 60 megawatt, 40 megawatt, 0 megawatt. Now, under what condition the output is 60 megawatt? Both the boilers are on as well as this generator is on. Right? Both. So that means, so you will say two boilers, both are on. Or I would say 260. What is the unavailability boiler? Previous question, same data. Unavailability data is same. 0.09. To the power 0. Because both are available. And what is the availability of the boiler? 91. 91 square. That is 0.91 square. Right? What is the availability of the generator? Since it is only one, you don't bother about the formula. We say into 0.88. So this is this. Right? What about when 40 megawatt will be available? Either of the one boiler should be on. That means 2C1 0.91 into so that is this 40 megawatts available. Because at least one boiler is on. Now suppose both the boilers are off. That means it is third case it will be 0.09 square as it is directly writing down. Because two boilers are out means both are unavailable. What about the generator? It doesn't matter. It doesn't matter. Right? Because if both the boilers are out and the generator is in service, then the output is 0. Or with plus. Both the boilers are out and the generator is out. Under both this condition, this or this output is 0. So that is the third one. So compute. This 3 compute. Okay. Now see the answers. Did you get this? First one is 0.14 to 144. Say that. First term data 0.7 to 878. Second term? Third term? Third term क्या हुआ? We have used one formula, but here we have another formula. We'll see that. We'll see that. आपका formula कितने बार? Just tell me the answer. घाटा होगा बात क्या? घाटा तो 0.1 loss होगी. 0.09 we'll see that, and we'll see where the formula is there. The answer is 0.000728. That is the formula I get. Okay. So that means some logic is wrong. So we'll see. It says where the generator output is 0. Okay, yes. So what instead we did? We did not take into account the case when both the boilers are up, but generator is down. That case we did not see. So that's why we say that. So either both down. So we would say both the boilers are down. That means 0.09 square plus both the boilers are down or the generator is down. What is the probability of generator down? 0.12. So we are actually finding out P, A or B. When Z A is both the boilers are down, Z B is generator is down. So that is equal to solution. So here actually we have considered only one unit. Only one unit we have considered, one part. But we have to now take this model as one unit and there are two such things. There are two such things. So that is the whole system. Okay. So for that, okay, for the whole system, this is our answer. So for the whole system, what is the case? The first case is available output 120 megawatt when both these systems are on. So what is the availability? What was the first case? 120 megawatt output? 728 square because both should be available. Then only the output is 120 megawatt. What about we have got for the unit 60 40 0. So we have one case where the output will be 100 megawatt because one will be outputting 60 megawatt, the other will be 40 megawatt. So that probability will be 2C1. 2C1, that's why 2 into 1 unit 60 megawatt, which is 0.72878. You can see there. 1 unit 40 megawatt, which is 0.14414. And therefore, this is the problem. 80 megawatt, both 40. So that's why 144 square. Okay. This is how. What about 60 megawatt? This is a tricky case. Okay. 60 megawatt means what? Either is outputting 60 megawatt. So that means 2C1. 0.72878, one is available, the other one is not available. 0. The other one is not available. 0 megawatt for it. So that is 0.1831. And 40 megawatt. Either one is providing 40 megawatt. So 140, the other is 0. 2C1. Okay. Therefore, this is the problem. Okay. And finally, both 0. So, last 2718 square. Yes. So, what is the expected output? How to compute this? That is, expected output is equal to 120 into 0.531044 plus 100 into 0.210084 plus 60 into 0.185283 plus 40 into 0.036649 plus 0 into. So that will come out to be. So plus 80 into 0.020773. When you combine all, your expected output is 98 megawatt. So this question can be a 4-mark question. The first question will be 2-mark question at most. So this will be a 4-mark question. Okay. So example 3 and 4. So 1 and 2 we completed. 3 and 4 will start next class.